Hi, good day. Myself, Dr. N. Vimal Kumar, Assistant Professor, Department of Mechanical Engineering, SRM Murray College for Engineering and Technology. Today we discuss about engineering graphics, GE 3251, Unit 1, plane curves. Specifically, we discussed about ellipse by eccentricity method. So, what is eccentricity? These are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line always remains constant. The ratio is called eccentricity. It is called E. For example, it have divided by three categories. For ellipse, E is less than 1. It is like 2 by 3, 4 by 3. Finally, its value is less than 1. Second, for parabola, E is equal to 1. Third one, for hyperbola, E is greater than 1. For example, 3 by 2, 5 by 4. The value is greater than 1. So, procedure to find number of divisions and the size of each divisions. So, for example, eccentricity is equal to 2 by 3. So, number of divisions equal to numerator value plus denominator value. Numerator value is 3, denominator value is numerator value is 2, denominator value is 3. So it's equal to 5 divisions. So size of each division is equal to 30 divided by 5. For example, if your total length is 30 mm in the sense, 30 divided by 5 is equal to 6 mm. This is called size of each divisions from the total length of 30 mm. So ellipse. Direct focus method concept. For example, the question is point F is 50 mm from a line AB. A point B is moving in a plane such that the ratio of its distances from F and line AB remains constant and equals to 2 by 3. Draw locus of point B. So here what is mentioned here, eccentricity is equal to 2 by 3. So initially we need to draw the directrix point, the vertical line AB. Next we take a center point, it is called C. Then C to draw the one straight horizontal line. Okay, then what is the total length? 50 mm. So eccentricity is 2 by 3. So its deviation is center point to vertex is 30 mm. Then vertex to center point is 20 mm. So in this concept the ellipse is involving in condition. So here C to vertex is 30 mm. So 10, 20, 30 mm. Then vertex to focus again 40, 50 mm. So totally 50 mm is the length. Center point to vertex is 30 mm and vertex to focus 20 mm. In this condition, we need to draw the eccentricity of the ellipse problem. Next, procedure. So draw the directrix, draw the horizontal axis perpendicular from a point C on directrix, mark a point F at a distance on the horizontal line at a distance of 30 mm from directrix. Fourth, make a point A, it is called vertex, by leaving two deviations from focus, each of size 6 mm, and then name the deviations as 1 and 2. Mark the remaining 3 divisions from A. Draw a vertical line from A so that AX is equal to FX. Draw a line joining C and X and extend it in the same angle and direction. After focus, mark the points 3, 4, 5, etc. so that each division is of 6 mm. Draw vertical lines crossing the points 1, 2, 3, 4, 5, etc. Mark the points 1 dash, 2 dash, 3 dash, etc. on the inclined line with 1 to 1 dash as radius F as center. Draw the arcs above, below the horizontal line on the line 1, 1 dash and name the points as P1 dash and P1 respectively. Follow the same procedure and mark the points P2 dash and P2 and so on. Join all points with a single stroke smooth curve to get an ellipse. So in this concept we did draw the ellipse problem, and next we need to draw the tangent and normal line. So this is the procedure. Make a point P on the ellipse, joined P and F, Draw the perpendicular to the line PF till the line meets the directrix at a point T. Join the points T and P for getting a tangent for the ellipse. Keep the protractor parallel to the line TP and draw the perpendicular line from P for getting a normal. So this is the sample ellipse problem from this procedure. First we need to draw the directrix. Next mark the center point directrix to the focus point. Total length is 50 mm. Here vertex to center point 30 mm. Here 20 mm. Next we need to measure the value of vertex to focus distance 20 mm. From this 20 mm we need to make a angle from using protractor from vertex point to the straight line is called, the distance is focus point. So 20 mm you can cut an arc from this center point to this arc point. You need to draw the one straight line. Afterwards you need to measure the vertex to 1, vertex to 2, vertex to 3, vertex to 4. It is equally similar divisions. It's approximately 10 mm for each divisions. And you need to measure the value from this point. This horizontal line to this inclined line, you need to measure the value. Here 1, here 1 dash, here 2, here 2 dash, here 3, here 3 dash. For example, you need to measure the value 1 dash value using the compass, and you can take the F point and make the arc in the 1 dash value. Next you can measure the 2 dash value and using the compass put in the F point, and you can arc in the 2 dash value, and you can measure the 3 dash value from the compass, and you can put in the F point, then cut the arc the same distance arc. You should follow the cut the 3 dash arc. That is similarly you need to measure the 4 dash value, then using the compass put in F value and cut the angle from 4 dash. Then 5 dash you need to measure the value, put in the F value, F point, this is focus point, then cut the arc from 5 dash. Similarly you need to cut in the above and down points also. So if one particular point, the 14 dash and F2 14 dash cut in the horizontal line, so you need to stop the number of iterations. Then you need to make an curvature from this continuous arc in every particular lines condition. So similarly you need to get the ellipse value. Finally next we need to draw the tangent and normal line. So here for example the tangent distance is 55 mm from the directrix. So in this condition, here this is 50, this is 60 from this directrix. So here is the 55 mm. So you need to draw the one vertical line for your assumption. Then this line is touching this ellipse. Okay, so you can mark a point P. Next you need to connect the line F to P. Then using the protractor, then put in the this similar line directions. So you need to fix the protractor, and here is the center point of a protractor. So in this condition you need to mark a value of 90 degree from the protractor. So approximately, so if you need to fix the protractor here, in the sense though the center point of the 90 degree, here you need to approximately coming here only. Okay, so you need to just roughly draw the line F2 up to this directrix point. Next so next you need to here put the name T. Here you need to connect the line T to this point P. This is the tangent line. Next we need to discuss about normal line. How to draw a normal line? The same line you should put in the protractor and mark the 90-degree, then connecting the same point in the P. You should draw the line. This is called normal line. Simple. So it's called RR, this TT. Now we have one similar problem for ellipse. Draw the ellipse by general method. Given distance of focus from directrix 50 mm and eccentricity is 2 by 3. Also draw normal and tangent on the curve at a point 50 mm from the focus. Here eccentricity is 2 by 3 is given and asking normal and tangent line at a distance of 50 mm from the focus. Okay. So this is the directrix line. The center point we marking. So straight horizontal line. The up to end limit is general name is actually whatever it is, we need to put some name. It is called D. Next, focus point 50 mm. We are using here ellipse eccentricity concept. So here we division 5 divisions. So next we mark vertex. Next, on straight line we can make a straight line. Then we need to measure the distance from vertex to focus. Approximately from this question, it is value is 20 mm. So you can make an angle of arc of 20 mm from the vertex, and you should take this center point to this vertex touching point, distance 20 mm point, to make a one straight inclination angle, inclination line. Next you should make a divisions 10 mm 10 mm divisions from the vertex. Next you can put the name from each deviations 1 2 3 4, the upper value is 1 dash 2 dash 3 dash 5 dash etc. Next you should measure the value of 1 dash, and you can, if you measure the from compass, then we need to afterwards we need to measure the arc. So by using compass you need to fix the F point and you can cut an angle in the point in the line 1 dash. Similarly you can measure the 2 dash value from the compass and you need to cut the arc from the 2 dash line in this focus point. Similarly you need to measure the 3 dash value and you can put the compass in F value. The same, the distance is 3 dash distance, and F2 3 dash, the same angle you can similarly prepared. Next you need to measure the 4 dash value. If you measure the 4 dash value, then put in the compass in F focus point. Focus point 2, you need to cut the arc from 4 dash value. Similarly you can measure the each point 5 dash 6 dash 7 dash, the up and down values also, down arc in particular point. For example 11, you should make a ellipse curvature. Initially the curvature is increased, afterwards the curvature is decreased. It depends upon the length of the vertical lines, 10 dash 10 dash 11 dash. So each values you can measure the F2 10 dash arc, F2 11 dash arc. Similarly once upon a time it's completed, ellipse is completed, we need to draw the tangent line. So the value is tangent is 55 mm from the focus. So you should take an arc from focus, the distance of 55 mm. Next Next we can use the protractor. From the center point is f, take a 90-degree value and put down straight line. This is the straight line. Then notice this point and this point. This is the focus point to ellipse is 55 mm. This is the tangent point. You should connect this straight line. This is called tangent line. Next we need to draw the normal line. So you should follow this line and put a protractor in this similar line and make a 90-degree angle from this approximately from this point and make the straight line. This is called normal line. Thank you.